The goal I had was to reduce this drying time from 3 or 4 hours to under an hour. And I thought if I could do that, well, then I'd really have something new. So the first thing I thought of was microwave, because, microwaves are fast. And so I called a friend of mine, and I said, what did he think about microwave drying? And he said, well, I'll talk to my father. His father was a specialist, a microwave specialist. He said, just use vacuum. He says, that's the best way to dry. We started working on a vacuum dryer, took it down to a neighbor of mine, an injection molding company, and he set it up and started to run it. So the goal of drying in less than an hour was achieved, because he said he didn't have to come in Saturday night. He comes in Monday morning, turns the dryer on, and he had dry material ready to go before his injection molding machine was up to temperature. A couple days later, he reported that the parts that he molded, his reject rate had dropped from 9% on these units to 0. Now, this was an additional benefit besides time saving. Now I had not only the benefit of time, shorter times, but I had a better dryer. Vacuum drying is inherently better. Desiccant dryers heat plastic and have to continue blowing hot, dry air for 3 or 4 hours. Well, you can't let the air go into the atmosphere, because it's heated. You want to recover the heat. So you recirculate the air, and you go round and round and round. And every time the air comes down, you go through a desiccant bed and pull the moisture out of it. And in some dryers, larger ones, you may even cool the air with cooling circuit so that you can get more moisture out of it while it's cool, and then reheat it again and go through it again. Well, there's two big problems with that. You're heating and cooling, heating and cooling, heating and cooling. So you're using a lot of energy. And the recirculation is degrading, to some extent, degrading the plastic. Now, that's not true of all plastics, but in some cases, in some plastics, it's very true. Nylon, PET, polycarbonate, they all would prefer not to be heated for 4 hours before they're processed. We don't do that. We blow hot air in the bottom, and we vent to the atmosphere. When we detect warm air coming out of the top, we shut the blower off, because we know that 90% of this hopper is up to temperature, and only the top 10% is maybe not quite up to temperature, and we just shut the blower off, and we shut the heater off. That's a tremendous energy savings, and it also means that the plastic is only exposed to the heat for 20 minutes or 40 minutes, if there's 2 batches in here. And we don't have to worry about a filter, because we're not bringing that air back, which may have dust in it. So we don't have to have a filter, which means it's low maintenance. Also, we don't have desiccant, which means there's no desiccant maintenance. Desiccant doesn't last forever. You have to change it. It tends to degrade. Nothing degrades. This is a vacuum. It'll work the same in 10 years as it does today. Talk about what I consider to be the most important aspect of vacuum drying versus desiccant drying, and that's energy savings. Generally, when people tell you there's energy savings, they're talking about a little bit. I'm talking about a lot, and I'm going to show you that with this chart. This is a graph. Let me just explain. On the left side here is watts per kilo. This is the energy that you consume per kilogram or per pound of energy that you dry and that you have to heat and dry. It starts at 0, which we'll call ambient temperature, the temperature of the plastic when it enters the dryer, which we've designated to be 80 degrees Fahrenheit or 26 C. Your target drying temperature, in this case, we're drying ABS, and our target drying temperature is 180 degrees Fahrenheit or 82 C. That's your target. That's what the dryer is going to raise the temperature. The dryer is going to bring the temperature to that level. This is the level that your injection molding machine has to get the plastic in order to inject it. And I've written that down as 380 Fahrenheit or 193 C. So one way or another in your process, you have to raise the temperature of the plastic to this point in order to inject it. If you don't have a dryer, then your injection molding machine will take it at ambient temperature and raise the temperature. There is a calculated amount of energy required to do that. And it's here. It's 66 watts per kilogram to raise the temperature from ambient to injection molding temperature. Your dryer takes it 1/3 of the way. Every dryer does that. That's actually all saved energy, because this section means your injection molding machine doesn't have to do that. So your injection molding machine has to provide this much energy to get it up to temperature, molding temperature, but your dryer already preconditions it by you're putting in this much energy. Now the 3 bars are vacuum dryer, the best desiccant dryer on the market that we could find, and basically popular desiccant dryers, which represent probably 95%, if not more, of the dryer market. I'm sure that if you're running a desiccant, a wheel dryer today, it's one of these. The point of this chart is to say every dryer has to put that much heat in there. And it's not the fault of the dryer that they have to do that. They're actually helping the injection molding machine. It's what you use above that line that is what I'll call wasted, or its sole purpose is to dry the material. This is what vacuum drying does. It uses an additional 8 watts per kilogram. This is what the best desiccant dryer on the market we could find does. It uses an additional 38 watts per kilogram. The best on the market, by the way, was a European dryer, and it was a small dryer, and it had every energy-saving option you could imagine built into it. And this is the number they claimed. Our tests proved that number to be correct. That 60 watts per kilogram was correct, and that was that they claimed. But this is what a typical wheel dryer actually uses, 122. Now, if you go back 10 years, 122 was a good number. And it's still considered a pretty good number, apparently, because that's the #1 dryer that's sold. But this is your energy use with this one, and this is our energy use. And I'm just going to compare these two, because hardly anybody has this one, and even there we're better. But I'm going to compare it to what you're probably running now. This added energy is 100 watts per kilo. This added energy is 8. We're running 8, you're running 100. When you buy a dryer, I'm sure you assume you're going to have that dryer for 10 years. 5 years would be short, 15 years, we might be pushing it. I'm going to say 10 years. So you've got a desiccant dryer, and you run it for 10 years, and you run it with this added energy load versus this, and you're running, let's say 200 or 220 pounds an hour, 100 kilos an hour, and you're running a normal 80% uptime for the year, round-the-clock operation, and you calculate those savings based on what the electric company charges you, you will, with this dryer versus this dryer, and these are, let's just say these are $15,000 dryers, you will have spent $70,000 more here than you spent here. $70,000. When you make the decision to buy a dryer, you're stuck with certain fixed realities. You have to buy a dryer. It's not, do I buy one or don't I buy one? You have to buy a dryer. The next thing is, you have to live with the electric cost. There's no reducing the electric cost of a dryer. You can't tune it up better or anything like that. It is what it is. So you have to use the energy, and the electric company will send you the bill, and you have to pay the bill. So the only decision you have is, do I want to buy a dryer, let's say a $15,000 dryer, and then give the electric company an additional $70,000 over the next 10 years, or do I buy a vacuum dryer and only have to pay that much without that additional $70,000? I just want to add that we've sold 3,000 of these dryers, and we've been selling them for 18 years now. Most of these dryers are sold to repeat customers who recognize this reality, and that's why they buy them.